All right, it's 10 a.m., so it's time for us to go ahead and get started. Today I'm introducing the lab called Linear Graphing 2. So we're going to discuss that. I've already made a video that tells you more or less how it's going to be done, but this is just an intro to what all we have available for you so you can do it. This is one of the labs that's basically we've accrued the data for you, or we've collected the data for you. We actually gave videos as well of us collecting the data, and then, like I said, there's a video discussing how you're supposed to implement the lab from home. So let me go start off by just sharing my screen so you can see all that we have. Plus, I'm going to do a couple of reminders slash announcements for everybody taking this class. So I'm going to scroll through my modules and point out a couple things, and then go on to week 7 module for lab. It's called the week 7 lab module. So let me go ahead and do that. All right. So, first off, I wanted to show you there was a PT03 here, but I realized it only covered chapters 1 through 5, and my next test was not going to be 1 through 5. It's going to be 1 through 6. That's part of the reason that I moved it back to being due not on March 1st like it originally was, but I've moved it now to March 3rd. I've changed that on the syllabus. I actually changed quite a few dates on the syllabus. And when I change them, I usually will write under it changed and such a date, and you'll see that in red. And there's normally an arrow pointing to what I changed. The arrow sometimes turns out to be red, but generally it just stays black, so I can't do anything with that. Uh, but I wanted you to remember we have an online test, and that's technically test 4 because we had 2 online tests and then a face-to-face test. So this is the 4th test, but it's actually only the 3rd online test. That's why the label says PTO 4 O to OT 3, which means online test 3. Actually, I'll probably change that to OT. O3. But again, that's the online test. Now, that is practice, and you should do it as many times as you can. Like always, I take the highest score you get on each of them, and I average that at the end of the semester. And if, of course, if you skip a particular practice test, then you get a 0 for that practice test. And obviously, if you have an actual 100 at the end of the semester for your test averages, then I'll take that average, which is 100, and divide it by 20, which gives you 5, and that's the number of points I'll put on your final exam. Uh, However, if you don't do one of them, then you're automatically losing some of the 5 points. So keep that in mind. Now, additionally, since I'd posted the original practice test, if I see that that someone hadn't taken this one, what I'm going to do is look and see if they took the other one, and I'll give them the highest score on that. But again, that's me protecting your grade because I gave you 2 of them, but you'd be insane not to take this practice test from here on out to prep for the actual online test because the actual online test is going to include chapter 6, and that previous one that I thought included chapter 6 only included up to chapter 5. So make sure you do this one. Don't worry, it's not going to mess up your score. But if you go into the 3rd online test having only studied chapters 1 through 5, you're not going to be in a very good spot. That being said, I don't often give too many examples from chapter 6, or too many homework problems or test problems from chapter 6. Sorry, I said homework problems. I don't normally give a whole lot of them because there's limited things we do, and I don't cover the chapter 6 in its entirety. So, anyways, you won't be as bad off as you might think if you didn't cover chapter 6 because I normally that's a small fraction of this test, but it is going to cost you. So make sure you take this one, and don't worry about having to get 100. Obviously, strive for 100 so that you can do as well as possible. But if you end up getting less than you did on the other test, I'm going to change the score to what you got on the other test. Okay. The other thing I wanted to point out to you is that I've also made the online test 3 available. It's right here, OT03. T04. Again, that means the online test 3, but it's technically the 4th test, and it covers chapters 5 and 6. But as I explain in the intro and the instructions, and in my syllabus and in various lectures, All of my tests are comprehensive. So just because you're in chapter 5 and 6 does not mean you're not free of chapter 1, chapter 2, chapter 3, and chapter 4 questions. They will be on there. So notice there's a due date March 3rd by 11:59 p.m., just like the due date for this was March 3rd, 11:59 p.m. So that was the two things that I wanted to show you in addition to the stuff about this week's lab. The other thing I noticed is Tuesday, I actually created a week 7 lab and I can't find it now. I'm not a lab, a week 7 module for lecture, but I can't find it. I don't know if I erased it or what, but either way, I'm going to put it back up today. Y'all can still always find your homeworks, but you should definitely have a list uh, that has the videos that are applicable to this chapter. Specifically, chapter 5, what we just finished, and chapter 6 is what we started last or the night before last. So no, it was last night. We had started it last night. So, anyways, there are various things for chapter 5 in here. That's not a problem, but I don't have anything for chapter 6 yet. So that will be in this week 7 module. I'll change the date and set it up, but I swore I had already done it, so I don't know what happened, and I apologize for the delay. So this is a video where I originally made the lab, and then I just discussed how you're going to implement it. This is the actual lab document that you're going to fill out. I'll zoom a little bit so you can see everything. So this is linear graphing 2. Again, all this apparatus is stuff that we've accumulated and put used to make the actual data. So you will have the data, but we are trying again to graph things that may or may not be actual linear, but rendering them in 3 dimension or in linear ways so that we can basically change the two variables to, like y squared and x to the 3.5 power or something weird like that. We keep doing that over and over again so that we can get eventually a straight line graph. Once we have a straight line graph, then we can do the simple linear fit that in principle you can do it manually, but we have Excel, and that allows us to do it with the root least squares method, and that's obviously as precise as you can get. So precise and accurate as you can get. But you'll see there's a part on density where they ask you to measure the mass in grams of 3 aluminum blocks and an aluminum cylinder and figure out all the dimensions of it, and then they're going to make a plot basically, and from that plot you'll be able to figure out the density. They explain to you how to do all that, and then they say print your graph. And always, we're not doing any printing, but remember, I do want to see your graphs, and I actually probably would want you to. I shouldn't say probably. I always want you to show me every graph that you did that you used, whether you ended up not settling on using a different graph or not. I still like to see those originals, and of course, the data is also supposed to be seen, and they're supposed to be in line in your document that you turn in. So, for instance, right here it says print your graph. So this is exactly one of the spots where I would be okay with you pasting a photograph of the graph in here and a separate photograph of the data. I say separate because often when students group their data and their graph in the same pic, they make it the graph and the data so small that I can't read the numbers and can't read the curve fit on the graph. So err on the side of making it bigger so that I can actually see, and that entails normally you'll have one image that you can share that's the data and another image that you can share as the graph, and both of them can be big enough where the font looks like it's at least 10 to 12. That's the bare minimum. I don't want to see any font that looks like it's smaller than 10 point or 12 point. I prefer 12 point, but 10 point's not horrible. So after you do the aluminum, there's one on kinetic friction, and again, it tells you how the data was collected. You should be reading this data so you can, reading these procedures so you can understand how it was actually put together. That'll also help you when watching the video and that sort of thing, but it'll also help you with understanding what all this stuff means. So you'll be filling in this. You'll have to do 3 trials, blah, 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 but I've got all that data for you. And then finally, you're going to, I think this is the last part, determine the acceleration of gravity. And you can see it's going to be basically using an inclined plane. We know that because it's mg sine theta tells us on an incline of angle theta, and the component of the weight that's parallel to an inclined plane is mg sine theta, and this is minus friction, and then that's all equal to ma. So this is Newton's second law. But if we choose our variables right, then we can make it in a form of y equals mx plus b. So what they notice is if you write this as A equals G sine theta minus F over M. So basically all they did is divided by big M on both sides. That got rid of the M here. That made F over M here, and that made just plain A on this side. So if you plot A on the vertical axis and then you plot sine theta on the horizontal axis, then the intercept will be the friction force divided by the mass, and you know the mass, so you can take that number and multiply it by the mass to get the actual friction force, and so on and so forth. I think that was the last part. Let me double check. Is it picket fence? Yeah, we got all that. So yeah, that was the last part. So ultimately, you're supposed to tell us what F over M is, and then calculate the friction and the slope of the graph. By the way, when you're plotting sine of theta, the slope of the graph would have to be G. So that's what you're seeing here. A is going to be the y variable, G is like M, and then X is sine theta, and then plus B is negative F over M. So we're adding a negative F over M as the y-intercept. So that's what happens when you graph sine theta on the horizontal axis and A on the vertical axis. The number one mistakes that students are still making is they frequently put the wrong thing on the y-axis and the opposite thing on the x-axis. So in this case, I'm pointing out to you that the a should be on the vertical axis and the sine theta, which is what we consider the independent variable, will be on the horizontal axis. G will be the slope, and like as I said, F over M, actually negative F over M, will be the friction force, or excuse me, the y-intercept, and then you can use that to solve for the friction force. So that's the actual document, and that explains more or less what we're doing in the lab. Now let me go back to the modules so I can show you the addendum so you understand what the addendum brings to the table so that we can do the lab. So I go down to module lab module 7, and here's the addendum, and you'll see it's just data. So here's the density part. I have a mass of 61.32 grams for a cylinder. Its diameter is 1.92 centimeters, and its length is 7.64 centimeters. So obviously, you need to calculate the volume of all that to help us calculate the density. But here's the measurements for one block, and that's obviously a mass 85.03, a length 3.15, a width 3.15, and a height 3.15 centimeters. So that's all the data you actually need for the density part. The kinetic friction part, you can see these are the masses that we used, and then these are the three trials that I showed you in that data table in your document. So that's how you're going to implement the kinetic friction lab. And then finally, the acceleration of gravity. Here's all the masses, the number of masses that we actually used. Here's the 0.009 is the height, and 0.018 and 0.027, 0.036, 0.045, 0.054, which of course just gives us the height in increments of meters. And here's the trials for each of those. We gave you the total mass of the glider was 286.3. That's the glider plus the little fence that rides on top of it. So you basically just have all the data you need. It's all listed in here, and that's pretty much all you need to complete it. That being said, I also gave you the following. Again, week 7 lab modules where I'm headed. And you see that I have right here acceleration of gravity. So you can see this is the actual demonstration of us running the experiment. So that's the cart we were talking about, and that's the flag they were talking about. And what you also notice is because we have a certain number of plates, those plates each raise it up, and that helps us to compute sine of theta. Remember, sine of theta is opposite over hypotenuse. So the hypotenuse for this, if you let it run the whole thing, it would be 2 meters. But whatever distance you did, the hypotenuse would be given by the distance it traveled, and then the opposite side would be the height of the side that's been raised. So one side of the air track will be sitting flat on the table like it's supposed to. The other one's going to be stacked up on top of something to make it tilt to a certain angle. So that's the video you're going to watch, and you can see the apparatus. Again, wanted to point out that this is the glider we're talking about. This is the picket fence we're talking about, and that binder clip is part of that mass of the cart plus flag. So that 286.3 or whatever grams that I found this to be, that included the cart, the little clip that's holding the picket fence on, and the picket fence. So now let me go back to the modules again and show you the other video, or at least show you the beginning of the other video. So again, week 7 lab module. The other video is the kinetic friction one. And again, he just explains, Dr. Wright explains how the kinetic friction lab is orchestrated. And you can see there's a force probe pulling a block. So this graph, static and connection friction, 12A, will measure the average force of the pull. It's not going to be precisely the same because the surface is not uniformly smooth and rough. Let's give it a shot. First, we're going to zero it out. Clicking on the zero here. It tells me that there's no force acting on the force probe right now. And we'll click on collect. Going at a nice steady speed. Like it's pretty steady. And there we go. Now we'll click and drag a box around the nice horizontal part of the graph. Looks like this thing. 2.01. That's the mean or average force that the force probe was exerting. We do it again. We do this 3 times, of course. All right, so that's the other video that shows you how the kinetic friction lab was done. And that's basically it. That's what you got to do for this week's lab. Remember, your labs always due 11:59 a week from today. So I've already made that module. In that module, I've already made in a assignment link, which is linear graphing 2. Notice it says it's due March 5th, which is a week from today, and it will be at 11:59 p.m. So make sure you guys knock that out. Remember, do not miss your online test that's supposed to be due Tuesday. Of course, you can do it earlier than that, and you get multiple attempts, and the same rules apply to the online test. Remember, you are allowed to do Google searches. You're allowed to have your book open. You're allowed to have your notes open. You're actually allowed to have other books open and possibly other people's notes. You're just not supposed to look at anything made since the test was posted, and today is the day we posted the test. So you want to make sure you don't copy or read or look at anything that was made after February or on February 26th or later, because, and again, my only reason for that is I don't want you to be able to game the system by one person that's seen the test making some kind of notes or web page or sending you a text or making up some homework problems or filling out a notebook or any of that kind of stuff using the knowledge of what was on the test to better inform you. So that's why I just say don't look at anything that was made or that was posted February 26th or later, because that includes everything that could have possibly been written about the test once the test was taken. So that's your rule for the online test. Again, my phone number is listed on my syllabus, so feel free to text me if you have any problems. You can also email me. I've told you that I do check my email every day, but occasionally I miss some. So if you don't get a response to me within one business day, if you will, as explained in the syllabus, then you definitely want to go ahead and text me and say, "Hey, Mr. Younger, I sent you a email and you never responded." So I'll fix that. But that's it. Let's stop sharing, and I will tell you guys bye bye. I'm going to be around here the rest of the day, but not working on this lab. So good luck, everyone. I hope you do well, and let me know if you have any questions. Have a good day.